All right. Hello, everyone. First of all, this is going to be a test file, so I'm not really sure about the quality of it. I'm sure for the next videos, the quality is going to improve dramatically. This is going to be the environment that you're going to see for your ANSYS workbench as soon as you open it. You're going to click on OK, and then you're going to go to on static structural. As you know, we have done for our course mainly some analysis of the static structures like beams, bars, trusses. Yes, we are going to do dynamics later, but for now, let's go with the static structural. You're going to drag it into your main workspace, and it's going to take a couple of seconds. Go to the engineering data. Okay, so from what you see on the table, you can specify a new material, or you can go with a library of the available materials. So I'm going to go with something, I'm going to call it test. Let's say I'm trying to use a material for the test that I'm going to do analysis on, and it's going to have its own Young's modulus of elasticity and other specifications that are not defined in the library of materials. So I'm going to define test, and for static analysis, we are mainly, as you know, concerned about the Young's modulus of elasticity and Poisson's ratio. So I will go to isotropic elasticity for test. Okay. And as you see, these two yellow highlighted areas are asking for Young's modulus of elasticity and Poisson's ratio, the main things that you are going to use for your static analysis. Let's say I want to go with 10 to the 9 uh, pascals or Newton per meter squared, assuming we are using the matrix standard, and the Poisson's ratio of 0, since we are not assuming the material to having any thinning or necking due to tensile or compressive forces. All right. The material is already defined now, so you can close it, and let's say later when you create your geometry for your analysis, you can refer to a material called test in your analysis. So I'm going to close this. Material test is going to be saved for this project. So I'm going to go with geometry now. Most of you are familiar with creating drawings, 2D and 3D in AutoCAD, and then for 3D in AutoCAD, SolidWorks, Inventor, Pro E. Oh, it's interesting to know you could import objects from those softwares, or you can create it here by itself. It has a pretty user-friendly environment and interface for using or for creating sketches in 2D and 3D. Let's say, for example, this is the interface you're going to have for your geometry, and I'm going to create an object in the XY plane. So I'm going to go to look at. I'm going to go with a couple of really easy 3D objects that you can create. For example, let's say I want to have create a 2D sketch that is going to be revolved around an axis and see how it looks like. So again, I will go to XY plane, look at. I will go to sketching, and then I will go and create a line. For example, let's say, by the way, that H that you see signifies the fact that your line is going to be horizontal. So then I will keep on drawing the lines, and there you go. Now, as you see, this is an enclosed area, so revolving it around x-axis is possible. If it was not enclosed, it would give you an error automatically because it cannot do any revolution around the x-axis. So if I go to modeling, remember, we are kind of happy with the way we have done with the sketch, so we can generate it and give it a sign of approval. So from there, we will go to revolve. It automatically, as you see, says, hey, is the sketch that you want to go and revolve is going to be sketch one? And you're going to say yes. Your axis, let's say you want to revolve it around x-axis, so apply. And then you can go to revolve and generate. There you go. This is the object that you are trying to analyze in 3D. Now, let's say I want to go and create an extruded object using a given sketch. First of all, let's get rid of the sketch that we have created. Well, if I go and delete it, it's going to give us an error, as you see. Is because it says you have to delete the revolve feature first. So let's delete the revolve, and then it lets you delete the original sketch that you created. Okay, let's go and create something that we will be extruding in the 3D space. So I'm going to go to XY plane again and go to sketching. Let's say we want to go with a rectangle like this. And then I want to go and specify the dimensions of it with the width of, let's say, h1 to be equal to 20 meters and a height or v2 of 36, let's say. Okay, so I can say I'm happy with the way the sketch is being created, so I can give it another sign of approval. I will go to modeling, sketch 2, and generate. Okay, let's say you are not happy with the way these dimensions are there. You can easily delete them if you don't want to see them. Anyways, okay, so this is the way you have for your sketches. Now it's time to go and extrude it. It automatically, as you see, chooses the sketch 2 that you already created, as you see, sketch 2, and you can specify the thickness that you are looking for. Let's say you want to go with 10 meters of thickness. There you go. And you can go and give it your sign of approval again, generate. There you go. This is the extruded object that you were looking for. So yeah, this was a test, and I will start adding more tutorials for the ANSYS workbench and regular ANSYS later. Thank you very much.